Hello class, these are our 4-7 notes. Sorry, I'm kind of moving them around here. For Algebra 1, today we are learning to use graphs to find average rate of change. So a couple things about the average rate of change. This is our big main idea for the day. Average rate of change, I'm going to abbreviate it like this. It's the average amount a function changes per some kind of unit interval. It's basically a slope. This is like slope. And calculated the same way. So if you think about slope we talked about y2 minus y1 divided by x2 minus x1. So when we subtract those y's, what we were finding was our change in y's, and then in the denominator we would have our change in x's. So we're going to call this, instead of x and y, we're thinking about input and output. So I'm going to call this average rate of change. And it's going to be our change in our output, which is like y, divided by our change in input, which is our x. So change, like if I am changing from 12 o'clock to 2 o'clock, right? I would figure out the number of hours that is by thinking, well, what's 2 o'clock minus 12 o'clock, right? That gives me 2 hours. That's my change in my x. Or my change in my y, I went from 40 to 45. Well, my change in y would be 45 minus 40, right? I would subtract to find that difference because we're looking at how much they're changing by. And again, this is kind of like an M. It is like an M because when I'm finding that difference between 40 and 45, I'm really subtracting them, right? That's y2 minus y1. It's the same thing. So we're just using it in a different context now. Instead of talking about the graph and just saying what's the slope of the graph, we're saying what's the average rate of change of the temperature. So it's something that you would hear more in real life. In real life, people don't talk about things like slope. They talk about average rate of change. So that's why we're looking at this today. So the first thing we want to do is we just want to go through and write a little description of the change in temperature shown on the graph over time. So I notice right away I want to figure out some things about the scale. It looks like if this is 10 o'clock, it must be 10, 11, 12. So this must start at 9 a.m. So we start looking at temperature at 9 o'clock in the morning. So we start measuring our temperature then. So that might be how I would start out my little paragraph here. And it is going to be a little paragraph. We're just going to do the best we can. We start measuring temp at 9 a.m. And then it looks like from 9 all the way until 2, our temperature is increasing. Well, it's not really increasing right here though, is it? So overall, it's increasing from here to here. It's not really going down, but it is kind of holding steady there. Our temperature increases until 2 when we have a maximum. So I'm trying to use words from our previous lesson, like increases and maximum. So let's see, after 2 p.m. our temperature decreases. After 2 p.m. our temperature decreases until the minimum at 8 p.m. when we quit measuring. Now this isn't very descriptive. I mean, I could definitely write more. I'm just highlighting those words from yesterday because I think that's how we're approaching it, right? We're approaching it like, what are the things we've already learned? What are the ways to describe graphs? Because I could definitely say something about how it's increasing from 9 to 10, and then from 10 to 11 it's holding at a steady temp, and then it's increasing, and then it's increasing again. It's decreasing like at different rates, first a little bit slower, or maybe a little faster at first and then a little bit slower. So there's all kinds of things that I could say. We're trying to just give a real general description here. It's a very open-ended question, so sometimes it's hard to know what we're looking for. Calculate the average rate of change from 9 a.m. to 2 p.m. So we already kind of talked about this. I've got to figure out that change in temperature and the change in time. So change in my output is my temperature. That's my y value on this graph. It's my vertical value divided by my change in time. So from 9 a.m. to 2 p.m., and we've got to figure out the temperatures to go with that. So let's go ahead and go back up to the top of our page here. So this is at 2 p.m. It looks like we have a temp of 45. At 9 a.m., we have a temp of 35. And if you had trouble figuring out the hours, we could just simply count the hour blocks. 1, 2, 3, 4, 5. So 5 hours have passed. So we're going from 45 to 35. So I could subtract them, or I could just subtract it in my head, but it's going to be 10 degrees. So I'm kind of doing this, and that's going to be 10 degrees Fahrenheit. And then our number of hours, well, we're kind of doing 2 p.m. minus 9 a.m., which is really awkward to write out, but it ends up being 5 hours. And so we are going up by 2 degrees Fahrenheit per hour is what that's saying. 10 divided by 5 is 2. So 2 degrees Fahrenheit per hour is what we're increasing by. And it is Fahrenheit because it tells me that over on the graph here. So the next thing I want to do is find the average rate of change from 2 p.m. to 8 p.m. So let's go ahead and check our temperatures there. So at 8 p.m. our temperature is 30. So remember we're doing change in temp divided by change in time again. So our temperature is changing from 45 to 30. So 30 minus 45. It's going to be a negative, but that makes sense, right? Our temperature is decreasing. So that's going to give us a negative 15 degrees Fahrenheit. And then while that's going on, our time is changing from 2 p.m. to 8 p.m. So 8 p.m. minus 2 p.m. These are both p.m. I can just subtract it 6 hours. And so when we divide that out, we get a negative 2.5 degrees per hour. So then our final question here is, when was the rate of change more drastic? So was it more drastic from 9 to 2 or from 2 to 8? So let's think about what that means. When is it changing more drastically means when was it changing more quickly? Well, my rate of change from 2 p.m. to 8 p.m., negative 2.5. Well, 2.5 is a bigger rate of change than 2. So the rate of change is more drastic from 2 p.m. to 8 p.m. when the temperature was decreasing. Because again, from 9 to 2 it was going up, from 2 to 8 it was decreasing instead. So putting this all together, making sure that we really understand average rate of change, because again, that's our main idea today, that we can look at a graph, we know how to find it, we know how to explain it in words and what that means. If the 2 points on the graph are, so here's my first point on the graph. My first point on the graph is a comma f of a. So a would be like my input. And remember, f of a means my output when I plug in a. And my second point here is b comma f of b. So b would be my input, f of b is the output when the input is b. And so I could find my average rate of change lots of different ways. We're going to kind of write them all out now. So I showed you earlier, we could do our change in output divided by change in input, and that will always work. And these are just different ways to look at the same idea. My output I could think of as these f of b and my f of a. Those are my outputs, so I could write f of b minus f of a over b minus a. So my outputs are the function ones. My inputs are just those letters b and a. I could write this as y2 minus y1 over x2 minus x1. That's usually when I write out slope, but it's really all the same formula. The other thing I will remind you of is if my slope is positive, that means my line is going up. Let's just write line goes up. Really, it's probably better to say graph, right? Because they're not always straight lines. So let's go ahead and write graph goes up. So if my slope is positive or my average rate of change is positive, my graph goes up. And my function is increasing. And when we talk about that, we really mean the y values, right? When we talk about a function increasing, we're talking about the y values. If my slope is negative, that means my graph is going down. Which means my function is decreasing. And again, that means my y values are decreasing. My y values are getting smaller. So big main ideas today are just this idea that we can look at our rate of change and compare rates of change, especially on a graph. And we know how to find an average rate of change. And that we could look at that in many different ways. That we could be asked to find an average rate of change based on the graph like we did here. Or we could just use some numbers, and that we know all of kind of these different ways to identify that average rate of change and talk about it. So again, average rate of change is just another way to talk about slope, and it's a way that just makes more sense in real life. As always, class, if you have questions, please make sure to ask.